All right, welcome to Chapter 4. I believe this is the last chapter that we'll do in Pre-Calc A. If we have extra time, we will start Chapter 5, but this should probably be the last chapter that we start. The title is Functions. Functions are one of the most important things that we will do all year, and it's very important when you get to the ACT test that you know about functions. So we're going to learn about some of the properties of functions. We're going to be able to identify a function. We're going to learn about domain. We're going to learn about range. Not quite doing much with zeros and graphing at this point, but domain, range, and to identify are the three main topics in this particular section. So let's get right into it. So first thing we're going to talk about is the definition of a function. A function is a correspondence or rule that assigns only one output for every input. Okay, you need to start thinking. When you hear the word input, you need to start thinking about x values, and outputs are y values. Okay, so when you hear output, you should think y, and when you hear input, you should think x. So you've probably seen f of x quite often. Okay, what f of x means is function. Okay, and what we plug into a function are called inputs. So our inputs are x values. Okay, our inputs are x values. Let's say I plug in 2 into my function. That means everywhere I see an x, I'm plugging in 2. So 6 minus 1 equals 5. So f of 2 equals 5. What does that mean? That means that when I plug 2 into my function f, I get an output of y. So let's label this down here. 2 are my inputs. 5 is my output. F stands for function. And what's another way of writing f of 2? Y. Okay, f of x and y are the same thing. All right, so if that didn't make any sense, let's look at it like this. I have a function machine. I know this is kind of silly, but it actually makes some sense. I'm going to say that my function is x plus 2. X plus 2. All right. Now, I'm going to throw the number 2 into my function machine. It's going to go into my machine. It's going to go in for x. And what should I get out? What is it going to shoot out when I plug in the number 2? Hopefully you see that a 4 will come out, because what is 2 plus 2? It's 4. All right, well, let's say I throw 4 into my machine. 4 goes in, it goes into my function. What comes out when I plug in 4? What's 4 plus 2? 6. Okay, let's say I plug in negative 5. Negative 5 goes into my function. What's negative 5 plus 2? Hopefully you see that that is negative 3. Now the question is, every input can only have one output. So is there any way that I throw a number into my machine and get a totally different number out 2 different times? So what is the only answer to when I throw in a 2? 2 plus 2 is 4. 2 plus 2 has no other answers other than 4. So this is a function. Okay. Now let me give you an example of not a function. Okay, so you're probably thinking, well, what isn't a function? Let's say I throw in the equation square root of 4. Square root of 4. All right. Okay, now, oops, sorry, let me get rid of that. Not square root of 4, square root of x, because we're not actually plugging in a number yet. Let's say I throw in square root of x. Now, let's say I throw in 4. 4 goes into my machine. It goes into my function. What is the square root of x going to shoot out? Well, hopefully you know 2. But what else is the square root of 4? Negative 2. So at this input of 4 has how many outputs? One input cannot have 2 outputs. Hence, this is not a function. Okay? So square root of x is not a function, because when you plug in a number, you get 2 answers to come out. Does that make sense? All right, so let's think about something in real life. Are birthdays functions? So B standing for birthdays, So B standing for birthdays. I'm plugging myself into the birthday function. When I throw myself in, what should come out? Well, my birthday is 4/16/1980. I was born on April 16th, 1980. Is that the only day I was born? So X is the input, Y is my output. I throw in Mr. Georgie into the function, only one number can come out. So yes, birthdays are functions. Okay? Someone doesn't have two different birthdays. You weren't born on two different days. Every person has one birthday. Therefore, it is a function. Okay? All right, so now to the tricky part of this particular section. Domain and range. Domain, the first one here, domain, let me get a marker. Domain is the set of all real number inputs. And remember, inputs and X values are the same thing. The range is the set of all output values or Y values of a function. Okay? So this is not going to make a whole lot of sense until we do some examples. So let's look at example number 1 here. All right, so now I have domain and range here. We're not even going to look at the graph yet, but this is how you're going to write it. It might seem a little tricky at first, but you're going to write domain equals, you're going to put a brace, that is a brace, a squiggly little parenthesis here. And you're going to put X with a bar after it, meaning your domain are your X values. So if we go back to the last definition, domain are your X values. Okay? Well, okay, the opposite is the range. Same thing, we have a brace, but now we're going to talk about our Y values for the range. Okay? So that's how you're going to start it off. Now, we're going to look at this graph here. Oops. All right, so what X values does this graph have? So I'm just going to go onto my graph. Go onto my graph here, and we're going to try some. Wouldn't you agree that this would be about X equals 1? If I go down to my graph, it has an answer. If I go to 0 and I go down to my graph, it has an answer. If I go to -1, I go down to my graph, it's on my graph. -2 touches my graph. -3 will touch my graph. These arrows mean it goes on forever, so this graph keeps going on forever. If I go to 4, it touches my graph. If I go to 5, it touches my graph. If I go way out here to like -8, eventually it's going to come up and it's going to touch my graph. So is there ever an X value that will not work? If I go way out here to like -15, eventually if I come down here, it will touch this graph down at the bottom. So every single X value is going to work for this graph. So how do you write that? You don't write every single X value, you just write this fancy R. And that means all real numbers. All real numbers work for X. Okay, so this is going to seem tricky at first, and then at the end, you put another brace to close your set. All right. Now let's look at the range, which is a little bit different. All right, so let me get rid of all this mess. Now remember that this line is going on forever; it's not stopping. So we're going to do the same thing with the Y's. Go to Y equals 2. And does it touch your graph eventually? Yes, it does. What about 0 for Y? Yes, it touches. 1, yes, it touches. 4 eventually is going to intersect this line because this line keeps going. What about -2? Yep, it touches right there. -4, yep, it touches right here. Is there any Y value that will not touch this graph? If you can't find any, then you're going to write an answer of, just like the last one, all real numbers. And then you're going to close your parenthesis, and there are your two answers for this one. Now, every graph is different. This one happens to be all real numbers for the domain and range. Well, let's look at this next one. This is actually the absolute value of X minus 2. So we're going to start domain, same way we did, parenthesis or brace, X with a bar. So you're telling me that the domain are X values, which is true. Now, let's look at the X's. I'm going to go to the X-axis, and I'm going to start testing some. At 0, does it touch the graph? Yes, it does. -1 touches the graph. -2 touches the graph. -3 will eventually touch that graph. 2 touches my graph. -1 touches my graph. Is there any X value that will not? These arrows mean it goes forever left and forever right. Remember, X's go left and right. So the domain, again, is all real numbers. Okay? Now, let me get rid of this. Now let's try the y's. Let's try the y's now. If I go to y equals 0, will it touch my graph? Yes, it does. Y equals 1 touches my graph. 2 touches my graph. 4 over here touches my graph twice. Touches twice. Now, what happens though if I go down to -2? Will it ever touch my graph anywhere? No, it will not. What about -1, which would be right here? Does it ever touch my graph? No, it doesn't. What is the first spot that touches my graph? 0. If you notice, 0 is the graph starts right here at y equals 0. And then it goes everywhere up. These arrows mean that it goes everywhere up. It never stops going up, but it starts at y equals 0. So how am I going to do this one? Okay, so y bar, y is greater than or equal to what number? What is the first y value that actually has an answer on the graph? Y is greater than or equal to 0. Okay, so this might seem confusing at first, but we're just going to run through a few examples. Okay, let's try this one. Domain. All right, so let's see here. I lost my pen. All right, there it is. X bar. Let's do the same thing we did before. Will this graph touch at 0? Yes, it will. 1 it touches, 2 it touches, 3 it touches, 4 it touches. -1 will eventually touch because this bar keeps going up and up and up. So yes, it's going to touch. Hopefully you notice that this one is all real numbers again. The arrows meaning that they're going out to the left, out to the right, never ends. Okay, now let's try the range now. Range might be a little different for this one. At 1, oops, I need my marker back. At 1, it touches my graph twice actually. 2, it touches twice. 3, it touches twice. 0, it touches twice. 1, it actually just touches one time. And if you notice, anything below -1, it's never going to touch my graph. Okay? So what should I write for my range? Y bar. Y is greater than or equal to, notice what's my bottommost point? -1. And there's my range. All right, last one here for the domain and range. Let's try this one. All right, so domain. It touches at 0. It touches at 1. It touches at 2. It touches at 3. It touches at 4. But as soon as I get to 5, it's gone. It doesn't touch anything because there's no arrow. It's actually a dot there. Same thing with the negatives. It touches at -2, -3, -4, -5, but this is actually an open circle, so it's actually not touching at 5. Okay, so this should make some sense from the last chapter. Domain is x. What x values is this between? It's between -5 and 4. So I'm going to put -5 on the left, 4 on the right, and x goes in the middle. And remember, what direction do your symbols point? Left? Left? The one on the right at 4 is actually has to have a bar because it is closed. It is closed there. The -5 is actually open, so I don't put it. So this graph goes between -5 and 4, and it stops. Okay? All right, now let's try range. Let's try the range for this one. So I'm going to erase my markings I've made, and let's do the range. If you notice, what is the very topmost point on my grid? 3, it touches, closed circle. -2, it touches, but it's an open circle. It's an open circle. So it's between 3 and -2. So just like this one. So y bar, instead of x, we're talking about y. So the y is between what two numbers? -2, and what was the top number? Top number was, 3. So it's between -2 and 3. So I'm going to put a 3 down here. I'm going to close my set. Symbols point to the left. Which one is closed? The one on, let me get rid of my markings here. The 3 is a closed circle and the -2 is an open. So the 3 was a closed, -2 was open. All right, so I know that's a little complicated. We'll make sure we do more examples. Okay. Now, how can we determine if something is a function or not a function based on the graph? Not every graph is a function. So we're going to use something called the vertical line test. So what I'm going to do is I'm going to take a vertical line and I'm going to run it across my graphs. Now this might be, let's see here. All right, so that's a little bit better. I can at least view this now. Let me. All right, so I'm going to take a vertical line and I'm going to drag it across my graph. Hopefully you can see this. Will this vertical line here that I'm shaking ever touch the red line at any one more point at a time? Okay, so it's only touching once, and it only touches once everywhere. As long as it only touches that red line once at a time, it is a function. So yes, this is a function. So I'm going to say yes, function. Let's look at this one over here. I'm going to have to make this one a little bit more transparent. All right, so let's try this red graph. Does it ever touch this red wave any more than once at a time? Does it ever cross my vertical line more than once? No, it doesn't. So it is a function. Yes, it is a function. So these two are yeses. Now let's go to the next page and show you a couple that may not be. Okay. So let me make this a little bit more transparent. Sorry. All right, let me do the same thing on this one. All right, now I'm going to take my line. Does it ever touch this circle more than once? So if you notice, if I leave it right there, how many times does it touch? It touches here, and it touches here. Automatically, not a function. It can never have one input having more than two outputs. Okay, let's look at the one over here. So I'm going to take my vertical line. So I'm going to take my line. All right, so let's look at this. It's like a sideways parabola. Will it ever touch the sideways parabola more than once? And if you notice right there, how many times does it touch? Touches once, twice. Not a function. So the vertical line test will tell you if something is a function or not a function. So I know that's a lot of stuff. I know it's kind of confusing. We'll make sure we do plenty of examples in class to make sure that you're fully aware what a domain is, what a range is, and determining if something is a function or not a function. Great job. I will see you tomorrow.